Well, hello there and welcome back for more Advent of Code. So last time we left on day 17, we had completed part 1, but we had no chance of completing part 2 with the same approach that we were doing. We would run out of memory and out of time before calculating these 1 trillion falling rocks that we need to simulate. So let's take a look at what we had on part 1. So here's the code, which is more or less, reasonable. It is simple enough, I would say. Pretty straightforward thing. We represented the rocks as pairs of XY coordinates, and then simulating them falling down into the chamber, which we are representing as a unbounded vector that we grow every time we put a new rock on top. But okay, the thing is that this works very fine to simulate 2022 iterations. So if we run cargo run 17, this should run fine, and this is the answer to part 1. But if we change this to be 1 trillion iterations, it takes too long. So one of the observations that we did the last session was that sometimes this is kind of like Tetris, and sometimes we get some rows completed. And at that point, at least for memory saving purposes, we can forget about all the chamber that is below that completed row, and just free up all that memory, and the program behaves the same. But that doesn't help us in terms of computing these iterations faster. It just bounds the memory that we are using to some bounded value. But one interesting observation that we have when we were trying that was that whenever we completed a row, there was always some leftover on top of that completed row, which I think is kind of a hint about what we can do, because maybe it would have been simpler if there was, when a row was completed, if there was nothing above that row, then we can probably make some easy calculations, knowing like which rock number we are putting there, like which of the 5 rocks it is that we have just put, because this is all cyclic, and which stream. So this the rocks are moved by a stream jet, or how is it called? Jets of hot air, and they are their behavior is mandated by this input. Like the jets maybe push the rocks left or right depending on this input, and it's a pretty long input, but I think it is 10,091 or 982. I'm not sure. Maybe we can print this and see. So I don't know. Here we can, I guess, println inputs length, I guess, because we're not having the new line at the end. It's just less than or greater than characters. So yeah, this is 10,091, and actually that number, does it have any divisors? No, it's actually a prime number. That's interesting. That also might be a hint, I guess, that we are not going to have any repetitions within the same stream, but after this 10,091 iterations, the jets of hot air are gonna be are going to start repeating themselves. But we also have 5 rocks, and since this is a prime number of jet airs, it's not divisible by 5, of course. Also because it doesn't end in 0 or 5, I guess. But after 10,091 times 5, which is something like 50,000 something, we're going to hit a point where we are starting to get the same rocks and the same jets of air. And I was wondering if things start to get repeated, like we can find cycles that way, in cycles of that size. Yeah, something along those lines. So we can probably check that. By the way, like, it's not like each rock corresponds, because each rock can consume a different number of jets of air. But I guess we can keep indices for those two. So I guess that's something I would like to check out. Well, what we just calculated, we can, I guess, put this into a variable, and let's say let jets count be this, and rocks count, I guess, be just rocks length, which is 5. We could hardcode that, I guess, but let's keep it at this. Let's also change this to this giant number and make it a U64. Let's have this iterator, because we're gonna use it, I think. Yeah. And what do I want to do? I would like to see, like, the top of the chamber every 50,000 and something iterations. So that number of multiplying these two together. So let's try to see that. And how should we do it? We're going to move the rock. We're going to do this loop. And I guess after we have put that rock down, we can maybe do something like if I mod this number, jets count times rocks count is 0, then we can print, I guess, the top of the chamber, and we can take a look at that. And I guess it would be also nice to, like, remember what was the last top of the chamber that we, like, from the previous time that this condition was true, like the previous 50,000 or something iterations ago. So let's have a mutable array for that, or vector, I guess. Last chamber, I don't know, top. And let's do just a vec new. Is it? Yeah, you can have a vector like this. It's fine. It is fine. We could maybe, let's see. Let's print line, something like iteration I, and let's print, how are we going to do this? We can keep, like, the top, print the top 10 rows of the chamber. So for, I don't know, j in this, let's do, how are we going to do this? Let last row be last chamber top, and I guess we could access it, but I don't want to have, maybe we can create just an empty vector here to like not care about out of index accesses. So maybe this can be even like a static array or something, because we are going to be printing and assigning this, I guess. Yeah, and I mean, in the first iteration, maybe I don't care about this. I would probably only care about this after subsequent, like when I is 0, I probably don't care about this, but we shall see. Let's just have something to print. We can do a vector of this and a row. What was row is just an array, right? So I guess we can default it. Can we do default this thing and have like 10 of this? Yeah, seems like it can. So we can now access this without worry. So what are we going to have? So last chamber count. So we have to print them the other way around, I guess. How are we going to do this? Like after we have printed this, we are going to assign this last chamber top to be chamber length minus 10 onwards, and let's just do to vec to just copy that thing, which I think should be fine. And here, I guess, can't we do something like last chamber top? When we are doing this, we are going to keep like the top. Index 0 is more at the bottom and the biggest indexes, so we have to iterate it in reverse order, I guess. So I guess we can do reverse, and we can actually have this extracted to a variable and say a chamber. This is the current chamber top. And put it here, and we can zip it, I think. Yes, let's zip it with chamber top, also in reverse order, I think. And this zipped iterator should give us the last row and new row, or current row, I don't know, something like this. And what are these things? Yes, these are rows. That is fine. Let's convert these rows into two little strings. Let's last row string the last row. Actually, we can map these things, right? Yeah, why not? It's gonna be, these things are just bytes, so if the byte equals rock, then let's put a character like this. Otherwise, let's put a dot. Well, let's make this thing actually be a string. No worry about that. You don't like this? Yeah, of course. You can be, I guess. No, I don't want you to be a user. It's probably I want you to as youth64. Yeah. last row string is of type string. And do you like this? That's weird. Let's roll with it. Cur row string is gonna be the same thing, but for the current row. Sure. And let's println both of these things. I guess we can do something clever like this. Last row string, and so we can compare these two things. Cur row string. And after we have printed this, let's print an empty new line. Okay, yeah, of course you don't like this because, yeah, it's a char array, but can't you collect it into a string? Yes, you can. Sure. Yeah, not the prettiest thing. But why did that complain, but not this one? That's interesting. Aren't these two things the same type? Well, I don't know, but let's cargo run this thing. Yeah, okay, last chamber top. Last chamber top is you're gonna be a vector of row. Look at that. And same thing here, we need to iterate and collect. So that is fine. Not the prettiest code, but this is just to get an idea of what we are dealing with. Iteration 0, and we have already subtracted with overflow aware in here. Sure, yes, because this is a U size and the chamber is not big enough yet. I'm totally fine with that. Let's just say I greater than 0 and the same thing, and let's run again. We're running in debug mode, so it might be slow, but we have some output. Okay, so in the first iteration of 5000 and something, we have this new top. Looks interesting because it has like a hole in the right, and we have nothing for the previous iteration. But then we have these, and they don't look similar. That's interesting. That is interesting indeed. But then they look, again, not similar. It's interesting that I would have thought that the things are going to be pretty similar, but this space to the right allows pieces to fall in here. That's interesting. And then they don't seem to lead. Oh, look at this. Even if we are on the same, oh no, but this, I'm doing this wrong. I'm doing this pretty wrong. I shouldn't be doing no, this is not the condition, because we don't know how many jets we have been consuming. I think we should, whenever we are iterating rocks and jets, we have to keep track of the rock index and the jet index. We are not doing that. So maybe here we could enumerate these two. And when we are extracting these things, rock is now not a rock, it is something different, but it should be an iterator. Okay, now this to vec is not what I want. Let's do rock index idx, I guess, and rock. Yes, usize and this thing, I guess, and then let's mutable rock to rock to vec. Okay, now rock is what we want it to be, and then the jet iterator. Yes. Interesting, very interesting. So here the jet iterator, we're gonna have the jet character, but also the index. So jet index and jet character. And what do we do with this rock index and jet index? Well, we have to use it here to know if we are in a cycle. But we don't have access. I guess we could do some funky stuff here. You know, when we break out of these, yeah, let's make it a bit ugly, but let's mute jet. Well, you know, we could, if we have something like this, we have to initialize it, I'm sure, right? Can we assign this thing in this assignment? Or should I be... We are breaking out of here, should stop. I guess we can do something like this. If not should stop, then continue. And then we are going to do this logic of dropping the rock, and let's move this debug printing and everything before the break, so we have access to the jet and rock indices. Okay, so instead of using I here, I want to see if like the combination of rock index and jet index is divisible by this thing. So how do we do that? Maybe just multiplying those two together. I think I might be missing something. Yeah, I think I am. If we consider, like if we were doing this rock and jet indices into a 2D matrix, like as if they are rows and columns, accessing an index of that, I don't know, let's call it J, just as kind of pseudocode, I think would be something like jet index times the rock count plus the rock index, I think. Something like that. And let's call this thing combined index. I don't know if this is a rock count is something else. Rocks count. These are all use sizes, which is fine. and we can see if the combined index is divisible by all of this. And I guess now you don't like this. Okay, I don't know. I don't know if what I just did makes sense, but let's run and see if something gets printed. And it seems it doesn't. So we are never getting this condition. Actually, no, we are not going to, because these things loop and these things are always. So I think. What if we ask if the combined index is 0? Because I think that sort of makes sense. We shall see. Maybe it doesn't. They are never 0. Why aren't they? Because we want to see if they loop. But when we drop the first rock, this is harder than what I thought it would be. We could say something like, okay, let's do something very silly here. Let's do print line of rock stopped at combined index combined idx, and just run. Well, we are printing a lot of things. You can see that here it sort of looped around and then started at 17, 68 and something. That's interesting. One thing that we could do is to sort of keep an array of those things. Keep an array of those things. Yeah, I just want to see if I have seen that combined index before, something like that. So yeah, maybe let's do something very stupid. Last chamber tops memo. Let's make this thing an array, static array of rocks count time jets count of what? Of just false values for now, like of booleans. We can then think of what we are actually putting there. Well, this cannot be a static array. Let's make it a vector, and it's gonna be 50,000 booleans, so it's not too big. That is fine. But we can do something like when we have dropped here, we can put last chamber tops memo at combined index be true. So now we can say something like if chamber tops memo at this combined index, well, if it is true, then let's print something. Like we have seen this. Combined index or combination of rock index and a jet. I don't know why I want these numbers, but a jet index already seen. And let's also print the iteration that we are in. Well, look at that. Does this make sense? I don't know. Process exit. I just want to see the first one when it repeats. What? Yes. What? At I,1000th? This doesn't make sense, or does it? Rock 1 and this jet. Huh. Very interesting. So we have dropped only 1,800 rocks, and we already seen a repetition. That's pretty interesting. That is pretty interesting indeed. Yes. Okay. And how did the chamber looked before? So instead of keeping these last chamber top, I think we should keep a vector of those things. Yeah. So instead of doing these, let's make this thing be a vector of optional vectors of rows. Look at that amount of templating, and let's start with them being all none. Okay, so now what we are going to do is, if we have already seen that, then we are going to do some sort of printing like this. Okay. And here, chamber top's memo, we are going to put the chamber top something like this. Chamber top. Okay, I'm not going to do this, and we are going to already seen. Yes. Okay, I'm starting to get a bit excited about this. I don't know why. Okay, last chamber top and current chamber top. We need to put the chamber top in here. We're probably going to need also some guard for guarding against the first iterations of this. But yeah, let's do something like well, actually we can say if there is some chamber chamber top being this, and we can probably guard these whenever we don't have. We can probably cap this. So yeah, don't worry about that. Doesn't this thing have like a last n? We can think about that later. So yeah, okay, we have the last chamber top and the current chamber top. Does this work? Probably here. What is chamber top? Okay. And what do you expect? Oh, an option. So yes, this should be some chamber top. Perfect. Combined IDX. Move occurs because has type blah blah, which is not in copy. Yeah. Just take a reference. And these sort of type checks, it seems, but underflow. Yes, we still have this underflow here. So how do we do this? I guess we can do something like we're doing chamber length -10. If it is less than 10, we have to do like, let's see, if it is, I don't know, 1, you have to just subtract 1 from here. So I guess we can do this and get the minimum of this as chamber length. There's probably a better way of doing that, but yeah. Woohoo! Look at that! Look at that go! Oh, and I am already seeing. Do you see what I see? This seems very repeated tops. That is very nice. Very, very nice. So, oh, this is really cool. Like when we start to see these things, we start to seeing them quite a few times. So let's let's do something. Let's do, I don't know. This is ugly. Just say, let's mute n. Like I want to not print this too many times. So let's say if n equals 10, process exit. I just want to have little, not too much noise on the console, and n plus 1. Okay, let's see just 10 of this. Okay, so they start at the iteration 1846, and they don't look the same here, the two tops. But I think this is kind of to be expected. Now these, pretty soon after, Rock 4 and Jet this amount, we see these. I'm really surprised of like the Jet numbers, but it's fine. Like, are we actually seeing? I don't know if we are actually seeing. Yeah, they are an actual repetition. Yes, but okay. Very interesting. One thing that I am thinking is that, yeah, this looks different. This also looks different. This also looks different. This was, for instance, rock 3 falling. Let's see, what is rock 3? It is the vertical var. So I don't know where that vertical var was dropped here. But this This looks very, very similar between these two. In fact, the difference seems to be only this thing. And then they start to look, these two look completely the same. But still, like if the next rock is a vertical bar, it can fall through here, through the right. So there are some gaps to still fall, and these gaps seem to be quite present usually, which is interesting. I wonder if I should have bigger tops, like a bigger size than 10 for memoizing these tops. So how do we detect that we are like repeating stuff? Because even if these two tops seem the same, since they don't have like you know, they don't cover the whole thing from the whole chamber from left to right, I cannot be sure that, you know, a piece cannot fall through this gap here. So let's increase maybe the size of these tops to something like 20. Just 20. So here, I guess this 10. This is the only 10 that I care about, right? Yes, let's make it 20. Then run again. And well, again, there are gaps. Well, always gaps to the right. That's interesting also. Seems there is like a tendency to fall towards the left. Oh, here we have something that covers the right, and they don't look the same. Very interesting also. Very, very interesting. I am thinking of maybe detecting when, like in a similar idea of what we did in the last session, detecting when we have a full row, and only in that case checking if we have seen that condition before. Because when we have a full row, it makes things easier, I think. I think it makes things easier. Because like we know that the top, you know, not any piece can fall through, and I guess we can be more sure that we are actually detecting a cycle, I think. Yeah. Okay, so here we are breaking, here we are dropping the rock. Should we do that? Or is there something more clever that I can do here? Like looking at these tops, I cannot really think of that. Yeah, we can do like the detection of the full rows, but still keep don't do the trimming of the chamber. Like I think we don't need to do that, at least for now, I guess. So okay, here we have dropped the rock. Let's also say let's mean same thing that we did before. This is gonna be I32, I guess. Now let's use usize. Let's max y equals usize min. So we want to know if we have completed a row. we are putting this here. So it's gonna be mutable. Min y is min y plus at the minimum of y as u size. Okay, and then we're gonna have max y blah blah this. So we are going to try to detect if there was a full row, and only in that case, I guess, we are going to do all this memorization of stuff. So say let's full row. We are gonna go from min y till max y, and see if any of those rows is full. So chamber y is just a row of rocks, so rock 7, something like that. Does this make sense? Yeah, I think so. Yeah, so let's say if not full row, we shall continue again. And let's also print ln full row on y. Well, we should see which one we are at. So full row, let's keep it, say let's full row y is this. Let's find one where this happens, and we can say let's sum full row blah blah, or else we are going to continue. Okay, here full row y, and here of course what are these y's? Yes, need to dereference that. We don't see any printing. Okay, we may have screwed up some things. Because before we used to see this, I'm pretty sure. But if we haven't seen it now, probably missing something here. The min-max calculation seems to be fine, but let's see. Println checking full row between min y and max y. Oh, look at those zeros. That's not good. What did we do here? These Y? Oh, these are the rock. Yeah, but the rock coordinates should be... This doesn't look very right. And now I remember that these rocks are I32s, and I mean, since we are dealing with big numbers, I think I would be better here using 64-bit numbers, just in case, even though they are signed. Yes, sure. Again, where were we? Why are these things 0, 0? What did I mess here? These are U size, and we are dropping things into the chamber. Once we oh, this continue is not really okay. If it should not stop, it should continue. This shouldn't be a continue. I think this should be a break because we are in this inner loop. Pretty sure that I messed that up. Yeah, okay, I did mess that up. Okay, silly mistake. So now we have full rows. That is nice. Look at those full rows. Before this, we didn't have any, or yes, we did have something. Look at this nice full row with just one thing on the top. So combination of rock 1, yes, and we are seeing seeing iteration, like repetitions of these full rows, and that's really cool. That is really, really cool. Okay, I am starting to like this thing. Because when we see something like, well, yeah. When we see like a full row like this, and the top of these two are the same, and we are on the same rock index and the same jet index, like everything is going to repeat just the same. And if we know the size, like this was the previous iteration, the thing on the left, if we know the size of the chamber at that point, and the new size of the chamber, we know how many, how much it has grown since these two moments, and we know like how much it has grown, and we also know how many rocks we have dropped. So we know that we know if you drop the same amount of rocks starting from this point, you are going to grow the same size. And yeah, we can probably calculate how much like we are missing from those for that 1 trillion, and do some sort of like just a multiplication to see like to get almost to the top, and then like finish up doing adding things in the normal way. I think, if that makes any sort of sense. Okay, this n is something that we are going to have to get rid of, but I'm feeling quite nice about this. So let's do, we are getting full rows we are getting, of course, more full rows than repetitions, but then we are getting some repeated patterns, and that is very nice. So we have full rows, we have repeated patterns, and yes. Okay. So what else do we want? In these things, I don't only want to have the vector of rows, I also want to know the size that the chamber was at that moment. Yes, the size of the chamber at that moment. To know the difference of sizes, of like heights, and then yes, use that difference. So is that enough? Is that enough information to like know the pattern and just do a straightforward calculation? I'm not really sure. Let's try. Let's do this and the U size. It would be better to have like a struct for this, but we shall see. Okay. Chamber tops memo. We have a sum chamber top, and let's also put here the chamber size or length. Okay. And here we are gonna have last chamber top and last chamber height. Yes. This spamming of full rows and the spamming of this is not necessary. We seem to not be using this, but I think we are going to. We don't need to keep 20. I think we can just keep, I don't know, 5, something like that, and say something like well, the full row, blah blah. Also, if full row y how do we ask if this full row is less than this is a U size. So so if this is between now what I want is this to be greater than chamber length minus 5, I guess. So chamber length minus 5. So yeah, it's to be contained within the last 5 rows. So if this is not the case, if it is less, I don't know if the equals is necessary here. To be honest, I don't know. Let's break. Let's try to see what gets printed now. Yeah, we can kind of see that the full rows are here. That is very nice. That is very, very nice, because we know that we have a full row, and we have a full row within these last 5 rows in the chamber, and we have the last chamber top, and if they are the same, we know that things are going to repeat. So let's actually test for that. So we can print this, and let's say if the current chamber top that we have extracted here is equal to the last chamber top, then let's print ln chamber tops are the same. And we cannot compare these two because they are probably not the same type. This is a vec of rows, and this is a reference to a vec of rows. I guess we can probably take a reference to this, and you're happy? Yes, you're happy with that. Chambers are the same. They have always been the same, and that is very interesting. That is very, very interesting. When we have a full row and we have the same combined index thingy, they are indeed the same. Very good. So we can also ask what were the sizes. What were the sizes? So chamber tops are the same. Let's say last height was last chamber height, and current height is well, chamber. I should probably extract this into a variable because I have used it quite a few times already. Oh, and we should probably, oh, this is how much it has grown. There's something here that I'm suspecting that I'm not doing correct. It's not just the height, right? It is like how many rocks we have dropped, because these things don't look. I'm wondering if the combined index, I'm computing this correctly. Shed index times the rock count plus the rock index would be the same to do the other way around, like rock index times a shed count plus jet index. I wonder. Let's see. So rock index times jets count plus jets index. I mean, they are not going to be the same numbers, but do we still get? Yeah, we still get sort of the same results. Okay. Already seen. This is the iteration. Interesting. Okay, and this is, we can have something like height diff is gonna be this minus last chamber height, and let's say height diff is this. I also want to know like rock, like fallen rocks diff. Which is how many rocks have been fallen, which should be the I number. Should be the I number. And we are not memoizing that. Let's do so. So we're gonna have this and another number, random number here, which is U64. This is not pretty at all, but we shall continue again. Last, this is chamber height. Fallen rocks count. And this thing we are going to put simply I+1 here, and fallen rocks diff is gonna be I+1 minus last fallen rocks count. Let's print this thing. Okay, interesting. I find it quite interesting that the loops are, like the diffs are these sort of numbers. They are not too big. They are not too big. And in fact, the first time we see this, is it before 2000? Yes, it's in 2006. It's before 2022. Very interesting. And it's already, yeah, things are already the same. Very, very interesting. Okay, so now let's try to do the speculative maths. If we know that since last time we have seen this fallen rock difference and it has grown this height, we should be able to increment this I by just a multiplication. But before this, I think we should change this loop to something like let's mute I, let's start at 0, AU64 0, and let's say we're gonna go until here. So while I is less than this giant number, yes, and when are we incrementing I guess outside of this loop, yes, we are going to just do I+1. So this is the same as the for loop that we were doing before, right? We are also exiting the process here, but if we go until 2022, I think we haven't changed anything in terms of like getting the answer. Yeah. Okay. So now let's extract this into also a variable. Can you? Yes, let's call this thing total rock falls. So we know how far away we are from that, and so how are we going to do this? The off by 1 errors are going to bite me here, but let's try. So we know, let's see, let's how many rocks we are, rocks away we are. I guess we could also like start from this number and go down. That might be, yeah, that might be better, I think. But we are using the I to count things here. So we can do that later. This print line is unnecessary. So let's see. Remaining, let's say remaining rocks is gonna be total or remaining false. This minus I guess, or I plus 1 because we have already fallen this rock. Sure. Let's also say remaining false. Is this? Typo here? Yes, sure. Come on. I guess we're gonna have a lot remaining. Yeah, lots of 9s here. Okay, but we have this remaining false. If we divide this, let's I don't know, cycles count. Remaining false divided by the fallen rocks difference. We can call these things actually remaining cycles. So let's print the remaining cycles. How many remaining cycles are we from? So okay, this is a more manageable number, like 500 million, but this is going to be times the height diff. Yes. And that is something that we have to add to the total of the height. So let's try to do it as simple as possible. This thing. Look at the amount of ugly variables that I have here, mutable things. This n should go away. This thing should go away. Yes. Here, let's do something like, let's mutable cyclic height I don't know, accumulator or cyclic height, yes, and let's initialize it, like let's be an optional and initialize it as none, and is going to contain an explicit type. Well, maybe you can infer it when I assign it to you. Cyclic height is going to be sum remaining cycles times this is fallen rock diff times height diff. Okay, and you are complaining because yes, you are of different types. That is fine. You can be I guess let's keep it to U64 to like be sure that we can compute these things. The cyclic height, let's also print this here, say cyclic height equals this thing. Okay, we are close. Let's print it as debug. That's fine. We are close. But before doing all of these things, let's see. Here's where we are dropping the rock. When we have already calculated this cyclic height thing, I don't want to keep doing this thing of like detecting cycles or whatever. So if cyclic height is sum, we're gonna break. Okay, and in the end we're going to do chamber length plus cyclic height get or no, unwrap or, I guess, unwrap or 0. And you don't like this because you want probably a reference here or something like that. No, come on, what is the problem? Yeah, types, okay, SU64, fine, and here normal 0 is fine, yes, okay. Does this run till completion? Does this run? Well, no, because we are also missing something else here. We are missing something else, which is to add this to I. Yes, because this cyclic height is like how much we are advancing. So let's actually put it like man, I got too excited there. Let's make it a variable here. Let's cyclic height, I don't know, yeah, underscore, whatever, 2, and print this thing here, because we are also going to add this to I, cyclic height 2, and we are going to assign it to cyclic height. Of course, this is all horrible, but it is in the name of trying to get to an answer. Does this now run to completion? Yes, it did. It did. Oh. And is this the correct answer? I am kind of worried to actually try it. I want to actually try with sorry, I don't know what I'm doing. With the sample input maybe, because I'm a coward. I'm a coward, and I want to see if the sample input will actually give us the right answer before trying the actual thing. Let's run with these. Is this not finishing? Oh, this is interesting. Why does the sample input not work? The sample input is much shorter, and doesn't the sample input get some completed rows? Maybe it does. Maybe there are no completed rows, which would be bad. Which would be bad. That's interesting. Okay, let's try out this answer actually then. I doubt that I have. Okay, let's compare it actually with the answer that we're supposed to have. This is man, it's a long number. So let's actually paste it here. This is our answer. We're gonna have 1 trillion and something, and the actual answer. Oops, I'm just typing whatever. I mean, the actual answer for the sample input is also 1 trillion and something. So they are pretty similar, very similar in magnitude. So that seems promising. Let's try. Well, that's not the right answer. Okay. I was too excited. We can return to this day and calm down the excitement. I probably got some off by 1 error or something. But I wonder what why this is not working for the sample inputs, you know? I'm guessing that maybe we are not getting any completed rows. So yeah, maybe let's print row at this full row y, row complete at this. Yeah, it seems like we are not getting completed rows whenever we're using the sample inputs. So let's maybe not break because of completed rows and not do any of this and see if the combinations okay. Something happened. So we have these patterns which don't look the same but look somewhat similar. Here we have a pattern that looks the same, and we have this final answer that ends with 4242. This doesn't look like the actual answer. Okay, let's copy this thing and let's copy the number that we should be getting. It is surprisingly close. Oh, very, very close. Just off by 40 something, right? Yes, look at that. No, actually, this is not the same. Yeah, well, it looks the same. Why am I not seeing this? Oh, because we are searching for full words. Yes, it's only 46 or something away. So we made some sort of dumb mistake here. Actually, do we get this? Do we get the correct answer for 2022? I wonder. With this sample input, 3050. No, we are not getting the correct answer. So when we run, with this, high diff, fallen rock diff. Well, when we are at I52, we are already seeing this, but yeah, evidently, like if we don't have completed rows for the sample inputs, we are not getting the correct answer. We could try to increase this top row number. Man, we are so freaking close, I feel like. 3057 and it is 68 what I want. But look at how thin this is. Yeah, they look the same, but they won't be. Let's do 20 maybe. Okay, we are getting the same answer here. I just realized something. Here we are getting the same answer, yes. Maybe in the sample input we might be getting some completed rows, but they are not within the last 5 rows on the chamber. But in any case, let's do something like this actually. U64 and run with these. Okay, this is a new answer. So what is it about this answer? This answer is actually closer, quite closer to what we want, but not quite. But I mean, if we are doing this 20 size, maybe now we can find some full completed rows. So maybe we can use that and see. Do we? Well, we should change this 20 here, I guess. So let's kill it. Do this. No, it seems like the sample input just refuses to complete rows. Even if we go something pretty big, like 100, I wonder. Like it never completes a row. Maybe it makes sense, I don't know. Maybe it's something that's, yeah, we shouldn't be sort of doing. But anyway, let's kill this. Let's change this. Let's see if the answer is different if we are comparing the top 100 rows. Oh, look at that. Look at that. That's a different number. Still even closer still to the actual. This is very, very close now. Only 6 away. That is suspiciously close. Remaining cycle height. Yeah. Very interesting. Am I having like an off by 1 error somewhere? So we are, what could be? Well, I wonder, like, changing this number has been getting us different results. So let's increase it by an order of magnitude and see. Well, now the printing is a bit slow. No, but the answer is the same. So that doesn't change the answer. With 100, we were quite okay. Right, this is the same answer as before. Okay, so we are fine with 100. Are we fine with 50? Wait, what is this? For some reason, this is closer. I wonder if we are messing up after we have put this cyclic height. We are breaking out of this inner loop after placing the thing in the chamber. Okay, that's fine, I guess. Wait, for 2022, we should be getting the same answer, right? Or was I debugging something there? 3044. Yeah, no, this is not the right answer. Why am I? Oh, because we are detecting cycles. And look at this. This is something that the cycle should be fine because we have some rows that are like not completed rows, but nothing can fall through these, so things are going to be repeated after this, and they should at least. Am I doing this combined index wrong? I cannot think of this. It seems to be a unique number for each row index and jet index, as far as I can tell. Sure. Then we are accessing this chamber tops memo by this, and that is fine. The cyclic thing. So yeah, if we are also failing for 2022, that is a sign that we are messing things around. 3068. So on iteration '81, this has already been seen, and these things are equal, and that is interesting. The chamber, okay, let's see. Here we have just put this rock, so this chamber lengths, we are good, like we have already fallen that rock. The I, however, hasn't been updated yet, so I'm wondering where are we using this I. Here we are updating this. Yeah, with this cyclic height. We are using I plus 1 here, and I plus 1 here too. I don't see the problem with this, but I'm suspicious of the I plus 1 a little bit. Oh, this I plus 1 also looks suspicious. So let's try and see what we get for this possible off by 1 errors. Well, here we got really wrong, so that's not closer. And this fallen rocks difference is weird. Last fallen rocks count. So this plus 1 is weird also. Now we are getting more, but what if we have no plus 1 in either of these places? 1042, 44, sorry. So it is the same as putting these plus 1s doesn't make the difference that we are searching for. Okay. Where did I mess this up? So if we comment all of these, we should get back to getting the same answer, right? Maybe I screwed by the checks that I was doing. Yeah. Oh, wait. Oh no, this is the correct answer. Okay. The cyclic thing I am messing. The cyclic thing I am messing. So okay, let's try to see the output then. And I'm tired of seeing this warning. Oh, I think I also should get going. So we have these two tops that look the same on iteration 81. So we are following the 82nd rock here. Fine. So fallen rock diff is 35. does 35 make sense? Here this thing has 40. Yeah, 40 is a multiple of 5, so, but still 35, I don't know if that makes a whole lot of sense. Does it? You know what? I am a bit suspicious about the combined index thing. Maybe we could the combined index, we could make it like simply rock index and jet index, like a tuple, and here make this memo thing, instead of being a vector, make it be a hash map of these two indices. So what are these indices? Are these U sizes? I think they are, right? Combined index is, yeah, U size. And instead of an option, we can put a non-option thingy here, I think. Yeah, and just initialize it to hash map new. Okay, and here I guess we can ask if there is one. Get, I guess. Yes, this returns an option, so that is fine. Combined index. Everything remains the same there. But I guess here we want to assign this thing, and combined index should be a reference. Okay, very good. You don't like this because cannot assign data to blah blah blah. Get, mute, insert, blah blah. So, okay. Can we do like entry for this combined index? But I don't want to do like or insert. I just want to insert something like this. What don't you like? Come on, entry and modify. Oh, look at that. That is very I mean, I just want to. Oh, wait. I'm confusing things. This is just an insert. Good old insert at this combined index. We're gonna insert this tuple. That's what I want. Yeah. Dang. That was too hard. So if we have now. Okay, we do have. It seems like the combined indexes were fine. Okay. So then we are messing up something kind of basic. Here we are adding, we are at 81. It's in at 81. height diff, fallen rocks diff, remaining cycles, cycle height, and let's also print like current height. I don't know what else to do at this point. I feel like I'm very, very close, but not there yet. What is the warning? Sorry. Come on, there is a cargo build. Oh, unused variables. Sure, yeah, no problem with this unused things, I think. So the current height is this, and we're going to add this height to this. And after that, we should be adding more things, but the cycle should be the same. Like nothing else should change, I think. Winning cycles 55, cycle height is that. Okay. So what is this? If we do this plus 129, oh, it's this. It's already this when we add that. And that doesn't seem fine, I think. Cycle. Oh no, we are adding this. Oh, that was. We are adding this to the cyclic height. Cyclic height to the eye. I shouldn't be adding that. I should be adding. What is it? The how many fallen rocks difference remaining cycles. So this is the cyclic height that we are going to be adding to the top of the height, like all the accumulated height, but to the eyes we should be adding the falling rock difference time the remaining cycle. Dang it, this is a stupid error. So remaining cycles times fallen rocks difference. Yes, and what if we run now? What if we run now? Yes, 3068. Yes. Okay, and we actually don't need this second variable, like stupid variable here. Let's do sum of blah 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 blah. Yes, and we don't need this. We can print debug this thing. I don't care. Or like just, well, yeah, print debug it. I don't care. Let's see what it prints now. Yes, okay. Let's go to the actual input. Save. And whoops, I'm too excited. Run. No, I didn't want to go to the actual input. What I wanted to do was save this. I want to do the actual big number of iterations. So run now. Yes, warnings, we can get rid of those. We can go back to the vector for memoizing things, but I don't care about that for now. I care about this number being the same, and I think it is. Yes, it is. It is the same number that we should be getting. Yes. Okay. Then I am a bit more confident now. Let's run for the actual input. Let's see. Okay, 12 milliseconds after and all the build time, the answer seems to be this. Let's look at what we have seen. Yes, this looks fine because it's covering left and right. Let's try this number. We are not doing the detection of full rows. Let's try this number. And yes, that is the actual golden star. That is pretty freaking sweet. Very good, very good. Yeah, I'm pretty happy with that. I'm pretty happy with that. Do I need something else? I don't think so. I mean, we have a lot of cleaning up to do on this horrible code, but I think, I mean, I should get going because I have something to do today. And this code is a mess. If we put this detection of rows, this kind of detection that we were doing before, let's see if we get the same answer for, can return to the Advent calendar. Oh, look at that, calendar has more things, and now I have the same golden stars as my age. That's very nice. And we get the same answer, it seems like, right? Yes, indeed, that was my answer. Okay, so this sort of makes sense. The detection of complete rows doesn't work with the sample input, but it does work for the actual input. So I don't know if it makes sense to leave this here. Also, the time it took went down to 2 milliseconds only, which is nice. Is it combined index? Yeah, I mean, there's a lot of things that we can do to improve this. Taking out the printing for once would be pretty good. Let's just comment it out for now. So we have a cleaner output. We have that. We can also have like the combined index be something akin to what we had before, like rock index times the jets count plus the jet index, and have this hash map be something like this. Everything else should remain the same, and if we run now, we should get the runtime decreased to even less than 1 millisecond, and we get the same answer. So this is quite good. And well, we can actually use the other way around here, the jet index times the rocks count plus the rock index. The answer, I think, should be the same. Yes, it is. I'm saying yes, it is, but I'm not really reading this whole number. It's just it ends on 201, and I'm trusting that it is the same. We can get rid of this jet count, and well, we have to also make this print the two numbers for 2022 and for 1 trillion. But yeah, as I said, I have some things to do, so I will be ending this session now. I will get back to the refactoring because that's something easier to do, but I'm glad that we managed to get the answer. And then the problem was a very stupid assignment here when we were increasing the I variable. I wish that we have discovered that maybe that's a good reason to call this I something else, like I don't know, like rock fall counter or something. Yeah, like rock fall counter or I or something, instead of just I, because we updated it with the wrong thing. But I think so far, yeah, this looks quite nice. I mean, it's quite more complicated, but I mean, I'm very glad with the answer that we got. The only thing that I don't like about like the idea of the answer is that this the detection of full rows doesn't work for the sample input, and I think, well, we can probably make something different for the sample input, like detecting, because it doesn't need to have like a full row. It's enough that the top of the chamber has some cover from left to right, yeah, to sort of say, okay, this top, nothing can fall through. But I don't want to do something like super clever, like a fluid field algorithm or something like that. Maybe just checking if there is a rock in each of the columns, like at whatever height, is fine also. But well, we can leave that for later session. For now, I'm gonna be disconnecting, and if you have been, thanks for watching, and see you next time. Bye bye.